to 8th grade math. For today, we're going to discuss about compound probability. So we are going to focus on the standard. The highly proficient student can compare different situations to determine the best prediction. Our learning objective for today is we will be able to calculate the number of outcomes of compound event, and I will calculate compound probability. By the end of this lesson, you will be able to answer these questions. What is compound probability and how is it calculated? So what is compound probability? It will be very easy for us to determine compound probability if we will go back and review simple probability first. So the probability of a simple event is a ratio of the number of favorable outcomes for the event to the total number of possible outcomes of the event. That means the probability of an event A can be expressed as the P of A. So the P there stands for that P stands for the probability, and that A stands for that event A, which is a specific situation. So the number of favorable outcomes, depending on what you are thinking or what you want to come out over the total number of possible outcomes, that is a simple probability. So let's have this um, finding outcomes of simple events. So for the simple events, you just have to count the outcomes. For example, one die equals 6 outcomes because a die has 6 numbers of it, and usually dice are used to start a game or to determine who goes first or to determine who will get a higher number or a lesser number. So that's how dice are being used. One coin has two possible outcomes. It can be a head or a tail. A deck of cards has 52 possible outcomes, and a fair number cube has 6 possible outcomes. What's the difference between a fair number cube and a die? A fair number cube can be corresponding to different types like colors or animals or sayings or days or months, whatever you want to write in there. You can customize it. Well, a die is specifically pertaining to numbers only. So that's the difference between a fair number cube and a die. But they both have 6 possible outcomes. Right. So a die, for example, your favorable outcome, what if you will be asked how many twos are there in a die? So your probability of getting a 2 is 1 out of 6. That is how you are going to write the probability of simple events. For a coin, what is the probability of getting heads? The probability of getting heads in a coin is 1 out of 2. Okay, so that is the probability. What about the probability of getting um, ace in a deck of cards? So let's say the probability of getting ace is, how many ace are there in a deck of cards? There are 4 out of 52. Right. Now, if you will say 4 out of 52, since it is a fraction, can you reduce that one in simplest term? Yes. Therefore, if you will reduce that one in simplest term, your final answer for the probability of having or getting ace out of the deck of cards is 1 out of 13. Sorry, that's 13. So 1 out of 13 is your probability of getting ace in a pile of or a deck of cards. And for the last one, what is the probability of getting, for example, let's say colors, a yellow? What is the probability of getting yellow in a fair number cube with 6 different colors? So that is 1 out of 6. So that is how you're going to write simple probability. So the P stands for the probability, and the number or the thing that is inside the parenthesis is your favorable outcome. How many of that favorable outcome is in there? That's your numerator, and the denominator is the number of possible outcomes. Okay, so now let's proceed to what if we are going to find out the outcomes of more than one event. Finding outcomes of more than one event is then what we call compound probability. So the total outcomes of each event are found by using a tree diagram or by using the fundamental counting principle. There are two ways to find the sample space. We call that sample space. How many possible outcomes can be there is called sample space. Now, if you want to be specific of knowing what are those, um, for example, let's say 32 things that are the possible combinations of these three things, then that's when you need to have a tree diagram. But if you will just be simply asked what is the possible number of outcomes if this thing will happen, or if you consider this possible of choices for this category and this choices for the another category, then you'll just use fundamental counting principle. And how do we do that? So let's have this example. At football games, at football games, a student concession stand sells sandwiches on either wheat or rye bread, and the sandwiches comes with salami, turkey, or ham, and either chips, a brownie, or fruit. Use a tree diagram to determine the number of possible sandwiches combinations. So, how do you make a tree diagram? I have it ready for you. So this is how you make a tree diagram. If you can see, the one up here are the categories. We have bread, meat, and side item. And for the bread, we have two possible choices. It can be a wheat bread or a rye bread. For the meat, we have salami, turkey, or ham for the choices. So it will be the same as the rye bread if you will choose rye bread. For the side item, there are three possible options. So you can choose chips, brownie, or fruit. So that will be the same if you will choose wheat bread with salami, then you can choose any of these three possible choices for side item. So your outcomes will be wheat bread, salami, or chips, wheat bread, salami, or brownie, or wheat bread, salami, and fruit. The same thing as turkey, we have wheat bread, turkey, and chips, wheat bread, turkey, and brownie, wheat bread, turkey, and fruit. The same thing as ham, wheat bread, ham, and chips, wheat bread, ham, and brownie, with bread, ham, and fruit. So for the rye bread, the same thing. So rye bread, salami, and chips, that's RSC. Rye bread, salami, and brownie, that's RSB. Rye bread, salami, and fruit, that's RSF. And rye bread, turkey, and chips, rye bread, turkey, and brownie, rye bread, turkey, and fruit, or rye bread, turkey, ham and chips, rye bread, ham, and brownie, rye bread, ham, and fruit. These are the specific possible outcomes that you will be able to make if um, you will give an option to those football players to choose whether they will choose that kind of bread with this meat and with what side item are they going to choose for that bread. So, how many possible outcomes are there? What is your sample space? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible outcomes. So this is one way of determining your sample space using a tree diagram. But in a tree diagram, you are so specific as to what are those possible outcomes. Another way to identify your sample space is using the fundamental counting principle. This is way too easy when you are just asked as to what is the total possible number of outcomes. So you will just multiply the total possible choices for bread, which is 2. For meat, there are 3 possible outcomes. So the bread can be wheat bread or rye bread. For the meat, you can choose turkey, salami, or ham. For the side, you can choose chips or brownie or fruit. So if you multiply 2 times 3 times 3, that is 2 times 3 is 6, times 3 is 18, you will still come up with 18 possible outcomes, which is your sample space. So this is way too easy, but if the question will ask you to do a tree diagram to specifically identify what are those 18 possible combinations, then you are going to choose the the tree diagram. Now let's take this example. Sometimes the number of outcomes changes after each event depending on the situation or depending upon the situation. For example, there are 7 students in the algebra club at Central High School. So the students want to stand in line for their yearbook picture. How many different ways can 7 students stand for their picture? So you cannot just say that's 7 times 7 because in this case, I'm going to use my board here. Oh, never mind that. I'll erase that. Okay. So for example, let's have students as A, student B, student C, student D, student E, student F, and student G. It will be easier to have different letters assigned to each student so that we can have them identified separately. So this is already one way of a formation for all of them for the picture in the yearbook. But let's take, for example, the A and the B, the first two positions. If A is already in the first position, so there, and you will say B replaces A, then you cannot have A and B back to that position. That means if all of them have 7 possible lines here, then in this case there will only be 6 possible things, because if you will say B, A, C, D, E, F, G, considering the B and the A, you cannot go back to A, B, C, D, E, and F, and G. So that means if A, C, A, D, A, E, A, F, A, G is possible, then B, A is also possible, but you cannot go back to A, B again because A, B is being taken here already. So B, A, B, C, B, D, B, E, B, F, and B, G. So you are, every time you make the changes for the first two position, or if you will say C will be here in the first one, so that is already taken. So you will be using permutations this time, 7 times 6 times 5, which we will learn later on. And the total possible choices here are, I mean, your sample space will be 5,040 possible mixture of lineup, which is 7 times 6 times 5 times 4 times 3 times 2 times 1. I'm not sure if I explained it to you correctly, but we will learn more on this later on when we get to that standard about permutations. Okay, so that is one of the situations wherein you cannot apply just the fundamental counting principle if you are in this specific situation. Right. Now, let's have this practice. What is a sample space? Use the counting principle for the first two, because in the third one, there is a specific instruction there that you need to use a, you need to construct a tree diagram for that. So let's have first a pizza company makes pizza in 3 different sizes: small, medium, and large. And there are 4 possible toppings: the pepperoni, sausage, green pepper, and mushroom. Since you're only asked to use a um, counting principle, then all you need to do is just to identify the number of choices for each category. So the sizes are small, medium, and large. There are 3. And for the toppings, there are 4 possible outcomes. So 3 times 4, that means your sample space is 12. Okay? Now, in the second example, you can choose from 3 types of sandwiches for lunch and 3 types of juice. How many possible lunch combination of sandwich and juice you can have? So for the sandwiches, again, let me use a different color. For the sandwiches, you can use, you have three types of sandwiches. It's not stated as to what are those three types. And for the juice, there are also three types of juice. So that means for the lunch, there are nine possible combinations. So that is using the simple or the counting principle for determining the sample space. In the third one, if we will use counting principle, it will just be very easy. So for the ice cream choices, let me use a different color again. I'm gonna use pink this time. Okay. So the ice cream choices, you can have vanilla, chocolate, or strawberry. There are three. And for the um, topping, it can be hot fudge or caramel. So that is times two. And that is six possible outcomes. But specifically, you're asked to make a tree diagram. So how do you make a tree diagram here? I'm going to show you how do you make a tree diagram. So let me change my board this time into, okay, this one. Now, so the possible flavors for ice cream flavors, IC stands for ice cream, is vanilla, chocolate, or strawberry. And for each flavor of ice cream, your toppings can be hot fudge or caramel. Hot fudge or caramel. Hot fudge or caramel. So your possible combinations are, you can have vanilla and hot fudge, vanilla and vanilla and caramel, chocolate and hot fudge, chocolate and caramel, and we have strawberry hot fudge and strawberry caramel. If you will see, there are six possible combinations, and that means we have 3 times 2 here. Okay, but this one here, these are the specific combinations, but still we have 6 possible combinations of ice cream and toppings. Okay, let me clear that one first, and let's go back to our presentation. So now let's have this example. Probability of compound events. A compound event consists of 2 or more simple events. Examples are rolling a die at the same time tossing a penny, or spinning a spinner and at the same time drawing a card, or tossing 2 dice and at the same time tossing 2 coins. So the same thing as our other examples here, like choosing, there are 2 possible options of pizza. At the same time, you need to choose a topping, in which there are 4 possible outcomes as well. So you have to mix them together and combine them. That is when you're going to you can identify the probability of compound events. So let's have this practice. I want you to identify whether this is a simple or compound probability. So if you will say Mary selects 1 marble out of a bag, is that simple probability or compound probability? So for me, that is simple probability, because there's just only one event that you will do. There's nothing else. And Jose selects a pizza, crust type, sauce, cheese, and 3 toppings. That is compound probability, obviously. Randy tells his brother he can have a cone or a dish of vanilla or chocolate ice cream. So there are only 3 choices for him. You can have either a cone, You can have a dish of vanilla, or you can have a chocolate ice cream. But there is nothing stated there that he can have a combination of each. So that is simple probability. And the third one is one that chooses a strapless, halter, or short sleeved dress. One that chooses a strapless, halter, or short sleeved dress. Is that simple probability or compound probability? As for me, that is only simple probability because all of them are just types of dress. And she's how what is the probability for her to choose strapless dress, or what is the probability for her to choose halter, or what is the probability for her to choose short sleeved? So that's only one out of three. The same thing as here. What's the probability for Randy to choose a cone? What is the probability for him to choose a dish of vanilla? And what is the probability for him to choose chocolate ice cream? That's only one out of three. And here selects a pizza. He selects pizza crust type. We don't know how many are in types of crust are in there. A sauce. He selects a sauce, whether it's a barbecue or whether it's a what other choice? So, buffalo sauce or whatever sauce that are in there. A cheese and three toppings, and we don't know how many toppings are in there. So it's obviously a compound probability. Okay, so let's stop for that. Let's have that one for today because our question, yeah, our goal for today is only to determine whether it is simple or compound probability and how to identify the sample space of a simple and a compound probability. So that is the end of today's lesson, and I'll see you again tomorrow. Have a great day, everyone, and hope you enjoy your rest of the day.